Hello and welcome to Maths on the Move, the podcast from maths.org. I'm Marianne Freiberger.
And I'm Rachel Thomas. We're continuing our mini-series leading up to the European Congress of Mathematics this year, which will be held in the beautiful Seville in July. And this episode features our interview with Artur Avila, who won both a prize at an earlier ECM, the European Mathematics Society Prize, and went on to win a Fields Medal.
Yeah, exactly. And the thing is that the EMS prizes are given out at every European Congress of Mathematics, and they're quite important because as we looked through past winners, we saw that quite a few of them actually go on to win a Fields Medal. Now, the Fields Medal is what many people consider the highest honor in mathematics. Both the EMS prizes and the Fields Medal come with an age limit. So for the EMS prize, you have to be under 35 at the beginning of the year that they're awarded, and for the Fields Medal it's under 40, so it's almost like there's a pipeline leading towards the Fields Medal. So we thought for this mini-series we will revisit interviews we have with people who won a Fields Medal who have previously also won an EMS prize.
So we talked to Artur Avila, who won his Fields Medal in Seoul in 2014 for his work on dynamical systems. Now, Marianne, you used to study dynamical systems before you worked here at PLUS. Can you give us an idea of what they are?
Yeah, so a dynamical system is just any system that changes over time. So, for example, the weather is a dynamical system because, as we know, it changes quite a lot, especially in England.
Hopefully less so in Seville.
Yeah. But you can also kind of abstract these things and just look at dynamical systems you get from mathematical expressions. So, for example, if you take the expression x squared and you say x equals 2, that gives you 2 squared, which is 4. Then you can plug the 4 back into the equation, into the expression. So it's 4 squared equals 16. So now you have a 16. You put that back in, you get 16 squared, which is a very big number, which I can't work out, but it is a new number, which you could then square again, giving you a sequence of numbers. So if you imagine those numbers on the number line, you kind of jump from one to the other. So in that sense, this is also a dynamical system. So it's these kind of abstract mathematical dynamical systems that Artur Avila works on. So, Rachel, you spoke to Artur in Seoul in 2014 after his lecture at the International Congress of Mathematicians, and something quite surprising happened.
Yes, I'd arranged to interview him after his lecture, and as I was waiting, he finished, and I stood up to go and speak to him, and he got mobbed by probably nearly 100, possibly more, young mathematicians who were there, both from South Korea, but also mathematicians who were attending the Congress, and they were just so excited to see him, and it was quite a moment, and I think he was quite shocked by the experience. Mathematicians aren't normally mobbed by fans. So the first question I asked him was if he had expected to be mobbed after giving a lecture at the International Congress of Mathematics.
Not at all. I didn't have any expectation becoming a mathematician of reaching any particular prize or anything. I just liked to do math, and I was delighted to have the opportunity to get quickly to study math at the institution where I did my PhD, IMPA, which I came from the Olympiads, and we had a lot of recognition that there was something amazing going on then at IMPA, and at that time that was my hopes getting into math, that I could one day become a mathematician and do something, and just for this. And then things were evolving, and eventually other things happened, but that was basically what I had in mind.
And your work is in the field of dynamical systems, and ones which are chaotic. Often when people talk about or read about chaos, they kind of think there's no hope for predictability, but your work, you kind of manage to tame them by classifying certain types of dynamical systems into one of two kinds, regular ones or stochastic ones. Could you just give me a feel for what the regular and difference between the regular and stochastic, of that dichotomy of those types of dynamical systems?
So, well, this is a feature not only of my work, there are many works towards this, but basically When many people, when they think of a dynamical system or see some system that evolves in time, they usually look to find some kind of periodicity in the system. So they hope to identify what's the actual cycle where things are going to repeat themselves whenever they see a time series. So, but this is not the general case. Like this may happen sometimes, but very often it's not like that. And so there is, so we could call this regular behavior, where the system is evolving and basically it's settling into some kind of periodic behavior eventually, which is easy to understand, and then you can make very simple predictions. But there is also possibility of chaotic behavior emerging, where it's characterized by the fact that a little instability in the beginning. So if you make a little error in measuring where you were at some point, later on you have a profound impact on what you actually see. So you see that kind of sensitive dependence to initial conditions is one of those features of chaos and other things. And basically, so those systems, you basically have to abandon hope of trying to describe it give a very precise prediction of what's going to happen very far away. But you can do other things. Like it's not because you cannot predict what a coin toss will give you that you cannot that you can say something useful. Like you can say that if you throw a coin 1 million times, you're going to get certain expected number of heads and tails with some variation and so on. The same for dynamical systems. You can get important, do some kind of stochastic modeling, which will give you kind of information about probabilities of seeing events and what can you expect about this. And for this can lead you to actually use those dynamical systems sometimes more efficiently than even systems that don't display as much as the dependence to initial conditions. So less chaotic systems can be harder to analyze than the most chaotic ones that you can find.
So although most systems aren't regular, they're not periodic, even if they're chaotic, you could be able to predict their long-term behavior using statistical kind of means.
Yes, you don't predict, you don't make the same kind of predictions. You don't kind of say what's going to be the temperature in 1 million years exactly, but you can say, well, of course, in practice, it is the systems are not given by these simple rules, but it should be equivalent of saying the average temperature along the next 1 million years will be whatever. So this kind of prediction that maybe is better, or even and have bounds of not how it oscillates in, with some kind of averaging procedures and so on. And you can say something intelligent about this. You have to ask the questions in a way that the statistical modeling can give you some information. Then it's possible.
And during your talk, I got the sense that if there's this dichotomy that almost every system of this kind is either regular or stochastic, that what's happening along the boundary of those two is interesting. Is that the sort of area that you're working on now? Or can you tell us something about...
That's the area that I don't understand, right? So for the moment I'm looking around it, like I'm not going straight to it. Maybe one day I have an idea and I get into it, but I don't believe that I can just force myself to just have an idea, and then at the moment I'm lost at how I would approach the actual critical dynamics.
And when we were reporting on this, writing our article about this at PLUS, we noted the very careful, mathematically precise definitions that almost all of these systems are either regular or stochastic. So there are some monsters hiding in the system that are neither. Is that true?
For one-dimensional dynamics, yes. So there are some that have a very strange behavior, which you might not have a single statistical law that's going to give you the information about all scales of time. So it can also evolve according to the time scale. It's called historical behavior. This may happen, and this kind of much more like that's more complicated to analyze. But fortunately, it doesn't happen with invisible way. And there are other possibilities. So basically, the regular stochastic theorem, it gives you so much because it says that all those other things, they're not kind of visible once you choose a parameter in random. And then you can forget about them and just deal with kind of the simplest, either the most regular systems or the others that you model stochastically.
And this is the first Fields Medal for Brazil. And you talked about the Institute IMPA and what a role it had in you becoming a mathematician. Do you think this will mean a lot to your fellow mathematicians, and particularly young mathematicians in Brazil?
I think it should mean, especially for non-mathematicians that might, young people that are not yet into math but like math and might kind of get more motivated to try math as a career. If you're already doing math, then you're already usually going to be motivated and in the right path.
Yeah.
Right, so but even before that, it may be it will motivate people that are considering or didn't consider because they didn't know it was a possibility, and now see that it can be a nice career.
And you've got the ICM in 2018 in Rio. So
2018, yes.
And will you be involved in that ICM there?
I will have probably I can help, like there's symbolic effect of the prize that they can use it to some effect to kind of get some publicity around it and so on. So in this way I help. I'm not going to work directly on the organization because I'm very bad with practical matters. So it probably wouldn't be very useful, and it would be actually maybe not very don't lead to anything. But I can actually help in different ways, and I hope to do so.
That was Artur Avila talking to us in Seoul in 2014. And looking forward to the next ICM that was going to come up after the one in Seoul, and that was actually in Rio, which is in Brazil, which is where Artur is from. So that was quite an exciting thing to look forward to. And it was an amazing ICM, the one in Rio. We very much enjoyed it. Stay tuned for more interviews with EMS prize winners in the run-up to the ECM.
Thanks for listening, and bye for now.